Okay, so the question is, how do we find the inverse function for f of x equals x cubed minus 7? Okay, this is a real simple process. So here are the steps you go through when you're finding an inverse function. Step 1, first thing you're going to do, and this seems kind of dumb, but it's helpful, is you're going to rewrite the f of x as a y.
Mm-hmm.
So you're going to get y equals x cubed minus 7. Okay?
Yeah.
Next step, and this is really important here. The next step is we're going to switch x and y. Okay? So that's going to give us, instead of a y, we're going to get x equals y cubed minus 7. Okay?
Okay.
Step 3 then is you're going to solve for the new y. Okay, so how would I isolate the new y? What are the steps I would do to get the y by itself?
Wouldn't you cube root it?
Well, okay, but you got to follow, when we're isolating a variable, remember we have to use inverse operations, right? So if I write down my order of operations tree over here.
Right.
We're going to use inverse operations. So the first thing I would have to do is any addition or subtraction.
Right, so you'd add the 7.
I'd add the 7. So I'd get x plus 7 equals y cubed. So there's step 1. There's no multiplication or division to do, but there is an exponent that I have to undo. And you were correct. How do I undo cubing something?
You cube root it.
Cube root it. Okay, so then I would get y. Well, this pen's not very good either. Y equals cube root of x plus 7. Okay, and then finally, the last step is we're just going to replace the y with an f of x or something like that, right? So that I'm assuming usually in books, when you want an inverse function, the way we denote that is instead of an f of x, we use a -1 exponent. It does not mean to the -1 power, but
Right.
we'll switch this to the cube root of x plus 7 equals the inverse of f of x then. And that's our answer.
Okay.
Okay? Does that make sense? So once again, the steps you go through is you're just going to replace the f of x with a y. You're going to switch x and y. You're going to use algebra to solve for y. And then whatever you get for y is your inverse function.
Okay. So the other problem that I had before that I had a problem with, I think it was f of x equals 47x minus 55.
Okay.
But then it was f. It was the inverse of f, or how do you say that?
That's fine. Yeah, the f inverse or the inverse of f of x. Yeah, that's fine.
Yeah, but then it's like of f of x, or
right. Okay, so you started off f of x equals, say it again.
47x minus 55.
So yeah, we'll just follow the same. We'll follow the same pattern then. So what's the first thing we do?
You'd add 55.
Okay, first I'm going to write it as a y though, right?
Yeah, write it as y.
Okay, so y equals 47x minus 55. Now what?
Then you would subtract, or
well, I'm going to switch x and y.
Yeah, then you would switch x and y.
So that's going to become, I'm going to get another pen.
Okay.
This is just not writing very well. I got to have another one here somewhere. Let's try this one. See if this is better. So I'm going to switch, and this is good because we're changing colors. This is perfect. Changing colors when we make our switch. Okay, so I get x equals 47y minus 55. Well, what is with my pens today, George?
I don't know.
I don't know what's going on here. I have terrible pens. They're all running out of ink at the same time. Here, I'm going to run up and grab a pen real quick. Hang tight.
Okay.
If F
Okay. Much better. So we had x equals 47y minus 55. Rewrite that. Okay.
Mm-hmm.
And then now I'm just going to solve for y, right?
Yeah.
So what are the two steps in order to get to y by itself?
Add 55.
Add 55. Good. So I'm going to get x plus 55 equals 47y.
Mm-hmm.
Then what?
Then we'd divide.
Yep. Divide by
47.
47. Yeah, divide each side by 47. So then we'd get the y by itself equals x plus 55 all over 47. Now, if I want to, I could split that up into two, not use a common denominator. And if I wanted to, I could write that as x over 47 plus 55 over 47, either way. Oh, and then the last step is I want to just replace that with an inverse, with my notation, F inverse.
Okay.
Right. But either one of those, I could either write it. I mean, to me, this seems easier. But I could also use that notation if I wanted to.
Okay. So another question I had is, let me figure out how to phrase it.
Okay.
So I guess I don't know how to say it, so I'll write it down and put it up to my screen.
Sure, that's fine. Yeah.
So
And you got to turn your screen on too, so I can see you.
yeah. Let me do that real quick. Okay, so how do you say this?
Oh, okay. So the inverse of f of x. Right. Okay.
Yeah.
So
Yeah.
right. So a couple things about that. So here's the notation here. This is when you're taking a composition of functions. So if we do something like f of g of x, that means that I'm inputting g of x into the function f of x.
Right.
Okay. Another way of writing that is like that. That's a little invisible, or not invisible. It's just a little tiny circle in the middle. And sometimes people you call that fog because
Right.
it looks like a small O in the middle. Those both mean the same thing.
Mhm.
Okay. So for example, if I had something like, let's just define two functions here. Like if I had f of x equals, let's say, x squared, and g of x equals 3x minus 5, then f of g of x would mean that I'm going to put into the rule f, right? And what does f ask you to do? When I input something into f, I square it, right?
Right.
So whatever f is doing, it's going to square something, right? But what's being put into that rule? G of x, right?
Uh-huh.
So it's going to be g of x squared, and what's g of x?
3x minus
3x minus 5. So that would be my answer.
5. Okay.
Okay, so if you have inverses though, here's something that's always true. If I have f inverse of x, in order for the test to determine if these are inverses is if they undo each other, right? So the answer is always just going to be x, because whatever f inverse did, f is going to undo that, and vice versa. If I did this, the answer is always also x. And if I use the other notation, that would be the same thing as saying f of f inverse. I think that's the notation you were using, maybe.
Yeah.
And the same thing here. F inverse of f of x is also always x.
Okay.
Okay.
So then, so like, if we took like the last problem, 47x minus 55,
Mm-hmm.
did that the inverse of f of x?
Right.
How would we do that?
Okay, I'll show you. So then, like on that last one, we had, here's our inverse, right?
Uh-huh.
And there's the original function, right?
Right.
Okay, so then all we're going to do, if we want to do, we're doing f of f inverse.
Yeah.
Is that correct? Okay, so
Or,
then
well, no, it's f inverse of f of x.
of f. Okay.
I think.
So then what's that going to look like? F inverse of f of x. I'll use the nested notation, okay? So then all that means is we're going to do f inverse of, well, f of x is 47x minus 55, isn't it? It's right there.
Yeah.
So that's what I'm going to replace for f of x. And then what's f inverse do? Well, here's my rule for f inverse right here.
Uh-huh.
F inverse of x is x plus 55 over 47. So if I plug something in, like if I did the f inverse of 100, wouldn't I just do 100 plus 55 over 47?
Yeah.
If I put in a z, I would just do f inverse of z equals z plus 55 over 47. It's telling me whatever I'm inputting into the inverse function, this is what I'm doing with that input, right? So in this case, the input is this whole thing. Okay, so then what that means is in my rule, my f inverse rule, well, here's the location of the input, isn't it? It's on the top. So it's whatever I'm inputting into the function is going to go there. And I'm going to add 55 to it and divide the whole thing by 47, right?
Right.
Okay, but what's going in there? Well, it's that whole thing, right? It's that whole thing. It's 47x minus 55, right?
Yeah.
Okay, so then all I have to do is simplify that now. Well, on the top, look what happens here. I get 47x minus 55 plus 55. Well, those just cancel. Those add to 0, don't they?
Yeah.
Okay, so then I get equals 47x over 47. And now 47 over 47 divides to 1.
Uh-huh.
So look, I get the answer x, just like I knew I had to.
Okay.
Okay, so I just showed that it worked.
Yeah.
The way that you verify that I got the correct inverse is I calculate f inverse of f of x, and I get back x. And then I do the opposite. I calculate f of f inverse of x, and I also get x. If I get x back both times, then I did it right. And it makes sense, because what do inverses do? They undo each other, right? The inverse of x cubed is the cube root of x, because a cube root undoes a cube.
Okay.
Okay?
Mm-hmm.
Does that make sense?
Yeah.
Okay.
It does. That's all I had. That's all the questions I had.
Okay. Yeah. Well, good.
Yeah.
All right. Well, this will be up on, it'll show up if you go to this Google Meet link later. There'll be a link to this video. But then also I'll just put it on the Google Classroom. I'll make a little resource for this where you can come back to this later if you need to.
Okay.
All right. Hey, you have a good weekend.
You too.
All right. See ya.
Bye.
Bye.